Hi everyone. Taking the topic as graph. So graph is a non-linear data structure. So first of all, what is data structure? So it is a way of organizing the data. So organizing means we are storing the data, retrieving the data. So storing means we are entering the data into the system. Automatically the data will be stored in the form of data structure. So we are having two different types of data structure. One is linear data structure, another one is non-linear data structure. So in this linear data structure, the data will be stored in the sequential order. For example, if you are storing the data, it will be stored one by one. So we are having a totally three different formats for linear data structure. One is list, another one is stack, and another one is queue. So we are having three different types of data representation in linear data structure. Another one is non-linear data structure. So in this non-linear data structure, the data will be stored in random order. So what is the meaning of random order? We are not representing any sequential order. It will be stored where the memory space will be available. At that place, the data will be stored. So in non-linear data structure, we are having two format. One is tree, another one is graph. So in this I am explaining what is graph and what are the usage of graph. So first of all, I explained that in non-linear data structure the data will be stored where the memory space will be available. So graph is, what is graph? So graph is consist of set of vertices and set of edges. So the mathematically we are representing graph is G equal to set of V and E. So in this V is vertex and E is edges. So in this each and every vertexes will be representing in the form of node representation. So for example, A is a information which is stored in the node. So node means in graph we are representing as a vertex. So edges, it is used for example, I can have two vertexes, one is A, another one is B. I can communicate with the edges. So in this graph, so A is a vertex, B is also vertex. So A and B is connected with the edge. So in this we are having different types of graph. So what are the different types of graph? So I can explain in this example A and B. I did not mention any direction between A and B. So it is representing undirected graph. Suppose I can explain with the help of the direction. So A tends to B. So in this the A vertex will be going to the B node. So in this the direction will be A to B. So it is a directed graph. Suppose I can mention the weight above the edge means it is weighted graph. So majorly we are having a various number of graph, but basically we are seeing these three types of graph only we are taking for the further process. So is a types of graph. So next one we are representing the representation of graph. So what is the meaning of representation of graph? So in this representation we are having two different types of representation. One is matrix representation, another one is list representation. So it is also called as adjacency matrix representation and it is also called as adjacency list representation. So what is the meaning of matrix? So you know that in mathematical we are representing each and every data in the format of rows and columns. The same thing will be used for matrix representation. So for example, in this graph, so V1 is one vertex and V2 is another vertex, V3 and V4. So I can communicate these vertex. So V1 is communicate with V2 as well as V4 and V3. So in matrix representation I can give a vertex value in row wise and column wise. So for example, in this representation V1 is going with V2. Automatically the V1 will not going with V1. So at that time the weight of the edge of the V1 is 0. And then I can go with V1 to V2. So directly the edge will be going to V1 to V2. So automatically I can put as 1. Suppose it is a weighted graph. I can mention here the weight of the edge. So V1 to V2, the weight of the edge is 5. So automatically I can enter the 5. Otherwise there is no weight in the edges means I can simply put an 1. Next thing is V1 to V3. So V1 to V3 is 1. V1 to V4 is also 1. V2 to V1. So it is not a direction graph. It is an undirected graph. So we can go in with V2 to V1. So it is 1. V2 to V3 there is no path. sorry, V2 to V2 also there is no path, V2 to V3 is also there is no path, and V2 to V4 is there having a path. So I can put 1. So next one V3, so V3 having a V1 having path, V2 there is no path, and V3 is also not having path, and V4 having 1. V4 to V1 is possible, V4 to V2 is also possible, V4 to V3 also possible, and there is no possible for V4 to V4. So this is a matrix representation for your graph. So next one I can represent the adjacency list representation. So purely it is based on the matrix representation. Once we are going to the adjacency list representation, in this concept we are using a pointer. So what is the use of this pointer? In this we are having a 2 paths in a single node. It is used to represent the vertex value, for example V1, V2 like this. This is used to pointing the next vertex. We are having the edges or adjacency to the V1. For example, I can give the V1. So in this V1 will pointing the what are the adjacency nodes in the V1. So how many vertexes is there? So I can point out this vertex V1, V2, V3 and V4. So in this each and every node having a 2 paths, one is vertex value, another one is link value. So in this link, what are the next vertexes or what are the adjacency vertex of V1? So adjacency vertex is V2, V4 and V3. So I can put the values V2, V3 and V4. So there is no adjacency matrix compare all these 3. So the last node will be pointing as a null value. So next one V2. So again V2 having adjacency node V1 and V4. V1 and V4. There is no adjacency nodes with the V2. And V3 having a V1 and V4. So V1, V4. The last node will pointing the null. And V4 having a V1, V2, V3. So I can put all the vertexes V1, V2 and also V3. So the last node will point in the null. So these are the representation of adjacency list representation. So each and every time we are using the pointer. So here the pointer will be used to pointing the adjacency node. So all the adjacency node will be connecting to the pointer variable. Okay.